we're just going to do a whole bunch of these simultaneous equations. I'm just going to be using the Casio calculator, just the good old Casio calculator. We'll see how we go. If we can see different ways of doing something, we'll do that. So this is going to be quite a long video, I think. These questions are all just literally just chat GPT. I just asked it to give me a whole bunch of simultaneous equations, and then I cut and pasted them. I haven't done them before now. Okay, so x plus y equals 10 and x minus y equals 2. So the obvious thing to do here is to add the bottom one to the top one, and we're going to do that because we want to get rid of the y's. So x plus x is 2x, and positive y minus y is 0y. It disappears. The equal sign comes down, and 10 plus 2 is 12, if my computer doesn't glitch out. So now that we know that 2x equals 12, we'll divide both sides by 2. They're going to cancel, going to go to 1. X is going to equal 6. Now that we know what 6 is, here's our answer for 6. We can just substitute that into either of these equations to find y. So let's substitute it in instead of this x. So this is now going to be 6 plus y equals 10. So it's just this top one there. Substitute it in. So we want to subtract 6 from both sides. So y is going to be equal to 4. And there's our final answer for that question. Is there another way we could do it? Yes, there is. We could have gotten rid of the x, and we'll do that in a second. Now let's get rid of the x. So these have the same sign, so this is positive 1x and positive 1x there. So I want to subtract the bottom one from the top one. So x minus x is 0x. It's a bit redundant to put that there, but I'll put it there so you can see what's going on. Y minus minus, so when you minus a minus number, it's the same as adding it. So it's going to be 2y. So positive 1x minus a minus y equals 2y. The equal sign comes down, make it a bit bigger. 10 minus 2 is 8, so 2y equals 8. I'm going to divide both sides by 2. They're going to go, and 8 divided by 2 is of course 4, so y equals 4. Same answer as before. And now I'm going to substitute that in there where y equals 4. So x plus 4 equals 10. I'm going to take 4 away from both sides. X is 6, and that is our final answer for that. Are there other ways of doing this? Yep, there probably are. And in fact, let's do that using the calculator. So I'm going to go to menu, equation there. 1 for simultaneous equations. There are 2 unknowns, x and y. 1, 1, 10, 1, minus 1. Make sure you make it a minus number, pressing that key there. 2, xe, and it gives us x equals 6, y equals 4, which is exactly what we have there. Again, more than one way to skin a cat. Just looking at this next one, I can see there's probably quite a few ways of solving this one. Let's just do them all. Let's do it by substitution. I'm going to need to sort of play around with this bottom equation first. I'm going to add y to both sides. So this becomes x equals y plus 1. And that's great because wherever we have an x in this equation, we can just substitute in that there. We can solve it for y in that case. So 2y plus 1 plus 3y equals 12. And now expanding out the brackets, so 2 times y, 2 times 1, 2y plus 2 plus 3y equals 12. Collect up the y's. 2y plus 3y is 5y plus 2 equals 12. I'm going to take 2 away from both sides and go up here. So I have 5y equals 10. 12 minus 2 is 10. And then I'm going to divide both sides by 5. And that is 2. So y is 2. So it's half of the equation solved, so I'm going to substitute that into this bottom equation here. So we start with x minus y equals 1, and I'm going to sub in there 2 in that case. So x minus 2 equals 1. I'm going to add 2 to both sides, so x equals 3, and there's our final answer. X equals 3, y equals 2. Let's do it another way. Let's solve this again by elimination this time. So we're going to have to play around with one or both of these equations, and what I'm going to do, I'm going to multiply this entire equation here by 2, I think. And so we get 2x minus 2y equals 2, and then I'm going to copy this one across. 2x plus 3y equals 12, and now it's going to cancel pretty nicely. 2x, and I'm going to subtract that is 0x. 3y minus minus is positive, and 12 minus 2 is 10, so 5y equals 10. I'm going to divide both sides by 5, so y equals 2, which is the same as we got before. And then I'm going to come along here to the other equation, and wherever I have a y, I'm going to put a 2. So x minus 2 equals 1. I'm going to add 2 to both sides. X equals 3, and that's the answer for that one. So our final answer for this one is x equals 3, y equals 2. Could we do this on the calculator? Yep, we could. So I'm going to go to equation again. I'm going to go to exit, 2 variables, and I'm going to put in 2, 3, 12, 1, minus 1. Remember, this is minus 1y there. And that equals 1. And then I'm going to solve it, and sure enough, it gives me x equals 3, y equals 2. Same answer. Next one. There's an obvious elimination here. We have a negative y and a positive y. So if we add them together, the top one plus the bottom one, we're going to get rid of the y. So 4x plus x is 5x. I'm not going to bother putting in the 0y now. 5 plus 7 is 12, so 5x equals 12. I'm going to divide both sides by 5, so x is going to equal 12 over 5. And I'm going to leave it as an improper fraction for now. And then I'm going to come along here, and in this bottom equation here, wherever I have an x, I'm going to put 12 over 5. So 12 over 5 plus y equals 7. Subtract 12 over 5. So y is going to be 7 over 1 minus 12 over 5, which is 535 minus 12, 23 over 5, and that's y. That's our final answer. X equals 12 over 5, y equals 23 over 5. Could we do that using the calculator? Yes, we could do that using the calculator. And we're just going to put those numbers in. 4, negative 1, 5, 1, 1, 7. Solve, and it gives us x equals 2.4, which is 12 over 5. I just left it as an improper fraction. And y equals 23 over 5, which is 4.6, is a decimal fraction, and that's our final answer. The next question here, there's another fairly obvious elimination that we can do here with the y's. 2y minus 2y. So if we add both of these equations together, we're going to get rid of those y's. So 3x plus 6x is 9x. 2y minus 2y is no y's. The equal sign comes down. 16 plus 4 is 20. And then I'm going to divide both sides by 9. X is 20 over 9, so 2 and a bit. Now I know what x is. I can just substitute that into either of those equations and find an answer. And let's do the top one. So 3 times 20 over 9 plus 2y equals 16. So 3 times 20 over 9 is 60 over 9 plus 2y equals 16. So I'm going to take 60 over 9 from both sides. So 2y, and they're going to cancel. 2y is going to be equal to 16 minus 60 over 9. It's a long day, so I'm going to use the calculator. I'm going to cheat. 16 minus 60 over 9, 28 over 3. And then I'm going to divide both sides by 2 again. So all of that divided by 2, and I think it's going to be 14 over 3, isn't it? Divided by 2 is 14 over 3. So y is 14 over 3, and there's our final answer. That and that. Could we do that using the calculator? Yeah, we could. As Bobby the Brain Heenan said, you know, win if you can, lose if you must, but always cheat. So 3x plus 2y, 16, 6 minus 2, 4. And when I solve it, x is 20 over 9. Yep, and y is 14 over 3. Yep, which is what we got. There's a couple of different ways of solving that, but that's the quickest, most obvious way of doing it. Again, for this problem, there's a fairly obvious elimination. These are both y's, one y, so one is plus y, one is negative y. So if we just add that whole equation to the top one, we're going to get rid of the y's. So 5x plus 2x is 7x. Y minus y is no y. 11 plus 1 is 12. So we're now at 7x equals 12. I'm going to divide both sides by 7. They're going to cancel. And our x is going to be 12 over 7. I'm going to leave it as an improper fraction for now. So x is 12 over 7. Let's do the top one here. Can sub that one in wherever we have an x. Put that there. So 5 times 12 over 7 plus y equals 11. So my 12 times tables aren't that great, so 4 12 is 48, 60. So 60 over 7 plus y equals 11. I'm going to take 60 over 7 away from both sides. From both sides, they're going to disappear, and y is going to be equal to 11 minus 60 over 7, which is a number. Minus 60 over 7, 17 over 7. And I'm going to leave it as a decimal fraction, as an improper fraction for now. So there's our answer there for x, and then there is our answer there for y. Let's jump on the calculator just to make sure that it works. Two unknowns, 5, 1, 11, 5, 1, 11, 2 minus 1, 1. Okay, so x is 12 over 7, moving down, y is 17 over 7, which is what we got. How about that? It worked. This question doesn't have something which is going to be just able to be eliminated straight away, so we're going to have to multiply one or both of these equations to solve for the elimination method. The obvious one is going to be the x is there because 4 is a multiple of 2, and these are both prime numbers, both of them prime numbers, so we're not going to get rid of the y's just yet, but let's get rid of the x's and let's multiply this entire top equation by 2. So 2x, 2 times 2x plus 5y equals 20 is going to be 4x plus 10y equals 40. That's what we're going to get for that. It really shouldn't be a equal sign. And then we're going to take that and we're going to put it underneath the second equation, so just so you can see what I'm doing there, and I'm going to put it there. And now when we subtract the bottom one from the top one, it's going to get rid of those x's straight away, and that's why we did it in the first place. So 4x minus 4x is no x. 3y minus 10y is minus 7y. And 18 minus 40 is minus 22. So we're going to divide both sides by negative 7. You're going to cancel. So y is going to be equal to negative 22 over negative 7. Are we done yet? Not quite. A negative number divided by a negative number is a positive number. I'm going to leave it as a improper fraction for now. So y is 22 over 7. And now we can come on to one of these. Let's do this one. So I'm going to copy the top one. 2x plus 5. And now y is 22 over 7 equals 20. So 5 times 22, brain melt. $110. Okay. So 2x plus 110 equals 20. I'm going to take 110 from both sides. So 2x equals minus 90. So x equals minus 45. Yes, must be right. Let's test it. Is that right? Does seem a bit on the big side. 2, 5, 20. Oh, over 7. Yes, I see where I went wrong. 4, 3, 18. 15 over 7, yes. 22 over 7, yes. That's where we went wrong. So it's over 7, so it's 110 over 7. And if we work that out, it's going to be 15 over 7. That's where we went wrong. Let's actually do that again. Alright, take 2. Let's do this so it's a bit cleaner. So we know that y is 22 over 7. So 2x plus 5 times 22 over 7 is 20. So 2x plus 110 over 7. That's where we went wrong last time. Equals 20. So 2x equals 20 minus 110 over 7. So 20 minus 110 over 7. 30 over 7. So 2x is equal to 30 over 7. And then we divide both sides by 2. And x is going to be equal to 15 over 7. That's the correct answer. The next one here has our, we're going to use substitution, has our Willy Wonka at the Chocolate Factory golden ticket. We have some variable by itself equals something else. That's great. That means that wherever we see a y in the other equation, we can just substitute that in its place. So 3x plus y, but y is also equal to 2x plus 1. equals 13. So I substituted that to that. So getting rid of the brackets, plus 1 equals 13. So 3x plus 2x is 5x, plus 1 equals 13. I'm going to take 1 away from both sides. They're going to cancel. And 5x is going to be equal to 12. Then I'm going to divide both sides by 5. They're going to cancel. And x is 12 over 5. Great. So y, now I'm going to put this in there wherever we have an x this time, is 2 times 12 over 5 plus 1. So 2 times 12 over 5 is 24 over 5 plus 1. And 1 is 24 over 24, so that's going to be 29 over 5. So x is 12 over 5 and y is 29 over 5. That's the answer for that one. Let's test it. Let's use the calculator and just blatantly cheat. But we're going to have to change things around a little bit. So I'm going to have to bring this 2x over, so I'm going to subtract the 2x. So let's actually just do that first. So our system of equations, this first equation here, I'm going to rewrite it, 2x plus 1. It needs to be in the form something x plus something y equals the constant, so I'm going to take the 2x over and I'm going to have negative 2x plus 1y equals 1, and then I'm going to copy the other equation here. In fact, I guess you could have just eliminated it from there, but it doesn't matter. 13, and then I'm going to enter it in that form into the calculator because that's the nice form that it wants. Two unknowns. Okay, minus 2, 1, 1, and then 3, 1, 13. Solve. Okay, x is 12.5, that's what we got, and y is 29 over 5, that's what we got, so our answers are correct. Cool. Again, for this one I'm going to use the substitution method and the elimination method. So it's already in that great form that we love, the Willy Wonka form. X equals something else. That means that we can substitute wherever we have an x, just this down here. So 2 times y minus 3 plus y equals 12. So see what I did there? I substituted that where we had the x into this whole equation. So now I want to get rid of that bracket, so 2 times y is 2y, 2 times negative 6 is 2 times negative 3 is negative 6, plus y equals 12. Collect up these y's, so 2y plus 1y is 3y's, minus 6 is 12. I want to add 6 to both sides. 3y equals 18. And now I want to divide both sides by 3. So y is 6. Now we know what y is. We can just go there and substitute that in now. So x equals 6 minus 3. So x is 3. And that's our answer for that. But you may be saying to yourself, oh, couldn't we do this by elimination method? Almost, we can almost do it by elimination method, but we're going to need to just reformat this top equation here a bit. We're going to need to bring this y from the right hand side over to the left hand side. So we're going to subtract y from both sides. So x minus y equals minus 3, and then I'm going to just cut that one there and paste it. So 2x plus 1y equals 12, and now it's in the format that we can use elimination. So we can add them together to get rid of the y's. So x plus 2x is 3x, minus y plus 1y is no y's. Negative 3 plus 12 is positive 9. So 3x equals 9. So I want to divide both sides by 3. They're going to cancel, go to 1. Divide that by 3 as well. Remember, whatever we do to one side, we have to do to the other side. And 9 divided by 3, hopefully you don't need the calculator for that, it's 3. So now we know what x is. We can go up here and substitute that in there like that and find it for y. So x equals 3. So x is 3 equals y minus 3. Oh yes. So I want to add 3 to both sides. So y equals 6. I'm going to swap them over. We can do that. And those are our answers. X equals 3. Y equals 6. Let's put it in the calculator just to make sure that we've got the right answer. And we have to put it in this form here in order to use the calculator. So it's going to be 1 minus 1 minus 3, 2, 1, 12. And then I want to solve it. X equals 3, y equals 6. How about that? Aha, now we have word problems. So a fruit basket contains apples and oranges, because of course it does. There are 12 fruits in total. Okay, that might be useful. And apples cost $2 each. Oranges cost $3 each. The total cost is $30. How many apples and how many oranges are in the basket? Okay. The first thing we do with any of these is to use the let statement. So I'm going to say let A be equal to the number of apples. And I'm going to let, I don't want to use O because it looks like a 0. I'm going to say let R be equal to the number of oranges. See there why I didn't use O for that, because you could have 0 O's and it's just a mess. Okay, and now we want to turn this into algebra. So there are 12 fruits in total. So we know that there are no other fruits, there are only apples and oranges. So in other words, the number of apples plus the number of oranges equals 12. So far so good. Apples cost $2 each and oranges cost $3 each. And when we buy our bundle of 12 fruit, it comes to $30. It's pretty steep for 12 pieces of fruit. These must be pretty good apples. So $2 times the number of apples plus $3 for the number of oranges comes to $30 And now we have simultaneous equation. Now we can solve it. Okay. Nothing cancels straight away, so we're going to need to multiply the... what are we going to do? Going to multiply the top one by 2. So 2 times a is 2a. You can see why I did that now. 2 times r is 2r. 2 times 12 is 24. So I want to subtract, because I want to get rid of those a's. 2a minus 2a is no a's. 3a minus 2a, 2r, is 1r. And 30 minus 24 is 6. So in other words, I bought 6 oranges. And now we know that the number of oranges and the number of apples is 12. So the number of apples plus the number of oranges, which is 6, adds to 12. If I take 6 away from both sides, the number of apples we're going to buy is 6. And that makes sense, because we have 6 apples, 6 oranges, we have 12 fruits in total. And let's test it. If we bought 6 apples at $2 each, that would be $12. And if we bought 6 oranges at $3 each, that would be $18. $12 plus $18 is $30. So our answer is there are 6 oranges and 6 apples. That's our final answer. Another pretty common question. This question has come up in exams quite a few times. So at a concert, adult tickets cost more than child tickets. A group bought 2 adult tickets and 3 child tickets, came to $75. Another group bought 4 adult tickets and 2 child tickets, and that came to $110. What is the price of 1 adult ticket and 1 child ticket? So I guess these guys bought their tickets and someone came along, 1 adult and 1 child, said, how much is that going to cost? Let's work it out. So first thing is our let statement. So let the let A be the cost for an adult, and let C be the cost of a child. The cost of 1 ticket for a child. Okay, let's turn this bit here. 2 adults and 3 children costs $75. So 2 times the cost of per adult plus 3 times the cost for a child equals $75. And here we have 4 adults and 2 children, and that came to $110. So what do we do now? Well, we have it set up pretty nicely. It's not going to cancel nicely straight away, but let's multiply this top one by 2 so we can get rid of the adult costs. So 2 times A, 2A is 4A plus 6C equals 150. So 4A plus 6C equals 150. And now we can get rid of the A's. If we subtract the bottom one from the top one, 4A minus 4A is no A's. 2C minus 6C is minus 4C. And 110 minus 150 is minus 40. So therefore minus 4C equals minus 40. If we divide both sides by negative 4, C is going to be equal to 10. So a child's ticket is $10. So now we need to find out how much an adult ticket is. Let's take this top equation here. So 2 adult tickets plus 3 children's tickets, which is going to be $30, 3 times $10, equals $75. Take 30 away from both sides. So 2 adult tickets is going to come to $45. Is that right? Yes, it is. That's right. Yes. So 1 adult ticket is going to be equal to 45 divided by 2. So what's that? 22.50. So therefore 1 child and 1 adult is going to be $10 plus 22.50, which is 32.50. Where are we going? Concert. Okay. Seems big jump. $10 to 22.50. If I've got that wrong, let me know. Alright, last one. Thank goodness. 2 friends go to a restaurant. Good for them. One buys 2 pizzas and 3 burgers, and that comes to $33. The other buys 1 pizza and 2 burgers for $19. Who's eating 2 pizzas and 3? Okay. How much does it cost for 1 pizza and 1 burger? Okay. First off, these must be pretty good burgers. And second, who was eating 2 pizzas and 3 burgers? No drinks, no fries. So okay. Let's not judge them. So what are we wanting to buy? So we want to know the cost. So let P be equal to the cost of 1 pizza. So presuming that all of these pizzas are all the same, they all cost the same. And let B be equal to the cost of 1 burger. Okay. Now we can turn it into algebra. So 2 pizzas plus 3 burgers came to $33. And 1 pizza and 2 burgers came to $19. What do we want to get rid of? Well, we want to get rid of the p's, I think, there, because 2 is a multiple of 1. So I'm going to multiply everything there by 2. So 2p plus 3b equals 33. And now I'm going to shove that there. 2p plus 4b equals, what's that, 48. So this times this is that. Now I'm going to subtract 2p minus 2p is no p. 3b minus 4b is minus 1b. 33 minus 48 is 15. Minus 15. Multiply both sides by -1. So 1 burger is $15. Wow. No, that can't be right. $5. -$5 is $5. That would be a really amazing burger. So 1 burger is $5. Now we know what 1 burger is. We can just come up here and substitute it in to either of these. Let's substitute in the top one. So 2 pizzas plus 3 burgers, and the burgers are $5, came to $33. So 2p plus 15, 3 times 5 is 15, equals 33. So 2p, take 15 away, is going to be 18. So 1p is going to be $9. So the pizzas are $9. And the burgers are $5. I still can't get over the 2 pizzas and 3 burgers. Wow. And that's that. That's the last one. Oh.